Not really sure what to call this yet. I'm not sure if we're going to call it the Static Net Homelab or if we're just going to call it Homelabs with Josh O'Brien or Homelabs with Crate Jockey, which is my gamer handle. I really don't know, but here we are, and we are going. So first off, I want to say thanks to everybody who has reached out. A lot of my friends and peers, mentors have actually already said that you've watched this, and I think most of them have been on the YouTube update because I just took the whole stream and threw it up on YouTube for the first one. We're eventually going to like slice sections out and put it up on YouTube for more instructional things, maybe even some of this. But I thank you. That's all I can say. Like I said in the last video, I've really been wanting to start content for a while, but to have my friends and peers actually reach out and compliment me and know that it's not just rah Josh, congratulations for doing something. No, it's like actual feedback. Whether it's I need to speak faster, whether I should cut it into more content, lots of different things. But again, just thanks. So tonight we're going to focus on the network. When I had you all here last time, we kind of walked through all of what's up on the screen. And like I told everybody the other day, this is the end state that we want. This network that you're seeing, and I'm motioning the screen, which isn't working, but this stuff that is on your screen. This is what the kind of end state network is going to be for the Homelab for now. That's obviously going to change as we try new things, experiment with new hardware, new software, that type of stuff, but it's what we have for now. With the entire point of this being the whole network to get us to this for the Homelab. And these are the critical pieces for the Homelab. Most of these networks, if not all these networks, were already set up in the network. And if you remember me talking about having a little bit of problems with Pi-hole the other day and saying I might not stick with it, I still had a bunch of weird networking issues. Like DNS would just drop out, things would just drop out. And I was having a hard time kind of figuring out what was going on. And then just randomly came back into the lab on, I want to say, Saturday afternoon after doing some stuff, and the lab link was down. And there's a lot of components that could go wrong with that. As we're going to talk, I'm running 3560Gs, which are old Cisco switches. They work great for what my path is from my garage and to the shed. It gives me a lot of interesting features, and it also just gives me a big switch for all the extra 1 gig ports I need here in the shed without buying another Unifi and stuff. But thought one of those could have died. Nope, they were both up. Could console into them. Everything was good. And then we have an underground path that we dug. If any of you have been following me for any long period of time, you know kind of the story from 7 years ago when we did the ditch witch through the backyard where they had already done the marking to show where all the gas lines and teleco and all that was. They marked all of it, and I went and got one of those self-powered ditch witches, and I just went for it. And then I saw rainbow spaghetti come flying out of the blade. And as a network / telecom engineer for my whole career, my heart sunk because I had just cut through pretty much one of the feeders for our entire side of town. Strangely, it didn't cause an outage for anybody. So I don't know if it was old buried cable. I don't know if it was just extra. I don't know. But that was a big deal, and they actually came out and did a whole bunch of other stuff. But all that said, we trenched. I eventually had to hand cut the rest of it, so because we didn't know where other potential issues were, since the marking didn't find the telco line. And then beyond that, we then put conduit in, and one of these days I'll give you a whole rundown of that. Ran underground conduit, did the detector tape, which I learned about, and then we ran power feeds from the house. But long story short, there is a single Cat 5 right now that runs from the shed, underground, to my deck, through conduit along the deck, and then into the back of the garage. That's eventually going to be outdoor rated fiber, probably a 4/8 pair fiber just to come out here. And then it'll be underground rated, and it'll be weather rated. So the point being, the circuit was down. I thought, I know some water got into that conduit because I sucked a lot of water out when we pulled the line through for the cable a couple weeks ago. I used the old shop vac and a baggy trick to pull the pull through line, and I sucked up a lot of water into the shop vac. So I knew there was water down there. So I thought maybe the cable just got too wet and shorted because it's just plenum rated cable. Yeah, I know, bad Josh, all sorts of stuff, but we used what we got to get the lab and the office up and going. So thought that could be it, but only one side was down. One side was showing lit, which I thought, no, both sides were down. Sorry, I'm wrong. But when I would move that cable to other ports, it would light up, and it would do it on both switches. So I knew it wasn't the cable, so we were good. So then we console it in, and sure enough, we had a spanning tree loop, and it had done its job, and it had blocked the port on the one side, and the spanning tree loop went away. That was odd because there's no physical spanning tree loop, but we had a whole bunch of different port configs from when I was getting things set up and from what the lab originally was when it was sitting in the garage for where it was when I brought it out here. And what it ended up being is, as I plugged things in, because I redid the whole lab over the weekend, cleaned up the cabling, ran all the 10 gig leaks actually before we did the first video, just to get everything wired. Didn't even really think about it. I thought just things aren't going to work that I need to work, and then I'll just go change the port configs and they'll be great. But no, like, we had spanning tree issues all over the place. And I'm not going to get into all the whatever it was, but I decided what it would be better to do instead of trying to piecemeal my way through it, since this is effectively a greenfield non-production environment other than local DNS for the house and DHCP off the Unifi controller, that we would just start over. So if we go into the Unifi and we go and we look at the config and the networks, you'll see that there is just the default, and that is 192.168.1 and a /24. And that is what I told everybody the other day is going to be our management network, because that's just how Unifi is the happiest, and I don't need to force my way down a path in the lab. I've got all the addressing I need, so we're not going to worry about it. So that is what we did, just burned it all down. In the process of doing that too, I had shown you guys the Homer, Homer dashboard the other day, which was my service catalog. And I want to talk more about service catalogs. I think more businesses need to use them. But it was the service catalog for the Homelab and for our house. And what that allows you to do is that allows you not only name things in DNS, but it allows you to then, have the link in a pretty little widget, and in some cases, some metrics and stuff for the service as well, if it's got APIs tied back to a widget. But more importantly, it lets you tie the ports in the full URL, which you can't just natively do in DNS. You can't just go to unifi1.nmw.staticnet.com, enter, and then it adds the 8443. Now, some devices redirect, and I think my Unifi controller actually does, but a lot of controllers don't. A lot of controllers aren't redirect everything here, because they might use different ports. Some of these are Docker containers on a Docker host. And I liked Homer. I actually even wrote some Python code to make it quicker to onboard into Homer and shared it with the Homelab community, and people seem to like it. But I also stumbled across Homarr, which is this guy right here. And it's another dashboard, another Docker container-based dashboard system, and it's just easier. We're going to go more into it later, but you're going to see it. I wanted to just address it because there were a lot of things done the other day that I've kind of switched up. And that's kind of the beauty of the Homelab in its current state, is that it allows me to play with things and kind of optimize. I'll probably go back to Homer for some things because I really like how simple it is. It's a single config, very clean to operate, very clean to migrate, do all sorts of stuff. This one's a little bit more complex, but it's prettier. And I'm going to not lie to everybody. The biggest reason I did it was the icons. All these icons are built into the config, into the Docker container for Homarr. In Homer, you actually have to go out and you have to find all your icons and download them. And I had more important things than messing with icons. People are going to call me lazy and that Homer's super powerful. And yes, I'm both of those. I was lazy about it. This is a quicker solution, and I like it. And it works really well. And it's just running in one of my VMs, which is this Docker host right here. And I'll just pull the hardware up real quick. 512 of memory, 1 processor, 1 core, Linux, all really plain Jane. Nope, that's the Ansible controller. Didn't click right. No, it's not. Ignore me. Maybe you should start ignoring me on a lot of stuff. But anyways, these just in general are really lightweight hosts running Ubuntu. and then running Docker. And then the other thing we did is I added Portainer. And if you're not familiar with Portainer and you're like trying to get into Docker and it's really like overwhelming to you, ignore that. I'm going to have to go cut that out. If you end up getting into Docker and messing with Portainer, you're going to find that it's just kind of a easy way to graphically manage containers instead of all the CLI stuff. And I will show you it just real quick. And then we're going to get onto the networking stuff. We're going to do about an hour stream tonight. I want to be able to break the networking stuff down really well and then go from there. So I am going to go ahead and mute my screen out because I'm going to pull up my 1Pass and I just don't know what it's going to pop up right off and if it's going to pop up on the screen. Yep, sure enough did. So we're just going to go ahead and get into 1Pass, get it over into another screen, and we're going to come right back into the live scene here. So from there, let me pull up my Portainer stuff. I actually did the smart thing and did dumb things and gave you my password again. So I'm going to have to go change that now. But I did actually a big automatically defined password. So what we're looking at here is we're looking at Portainer. This is the host. Portainer is actually installed on that host, and it's one of the containers on it. I don't even know if that's best practices for Portainer, but it's what I did. But if we do a live connect, you'll see really quick that you've got two containers, the Portainer and the Homarr one. Gives us the data, gives us their internal Docker IP addressing. It gives us the published ports for it. And then, yeah, it tells us that. And then as far as stacks, I deployed Homarr using Portainer stacks, which made it super simple. It was just a config that was right in Homarr's GitHub directory. Pasted it in, hit apply, changed like 3 lines through my local directories, and we were up and running. It was just gorgeous. And that's the beauty of Docker in general. But Portainer gives you a nice visual way to do that, especially if you're not in it all the time. All right, so I'm going to get rid of Portainer. We've talked about this. We'll come back to this screen some because it's got, our hotkeys for everything. As an example, like if we wanted to go into Pi-hole, I just click on Pi-hole 1, jumps us right in. But we don't need to be in there right now. So before we dive into networking, just going back to the whole DNS thing, DNS is great. Like it's how the internet works. Like it's a stupid comment that it's great, but it is just easy to work with once you get everything set up right. And Pi-hole, while not being the most powerful, most capable DNS server out there, there's a lot better. It's really good just for the Homelab because if you want to go add something, it's just as simple as going into local DNS, setting your DNS name, putting the IP, and hitting enter, and it's there. I've done some other things to actually do synchronization for both config and DNS config between my two, and we'll talk about that later because I'm going to rebuild that and show that in a demo sometime, probably even the next video. But beyond that, it's nice and simple, and Pi-hole works for the lab. I think we'll get into more complex DNS stuff later, but with the changes that we made to all of the VLANs, all the IP addressing the other day where I just nuked everything back to VLAN 1 and 192.168.1.1, everything is rock solid. I'm having no DNS issues. So there was some goofiness going on in the lab from just me plugging and pulling cables and not really being as focused as I should as I've been doing this. So with that, we are going to talk about VLAN 10. That's where we're going to start. There's a lot more to this. We have, as we go back into this diagram real quick, we'll look at it. And you'll see that there's all these VLANs we're going to have to define. So 1 through 6, and then 10 through 13. With 1 through 6 being VLANs that are effectively for the house, for IoT, for guest wireless, for all that stuff. But these VLAN 10 through 13 being very specifically for the Homelab. And as you can see over here, they sit on the data center or shed side of my network. And they are the production VLAN where the production interfaces will eventually land for all of the servers. So the way that that they actually communicate out to the world, and then likely some variant of an admin console for the Proxmox on that too. But I'm also going to attempt to split the management interface into VLAN 1 and the production interface for that for all the servers onto that same 10 gig port, but then separate them through VLANs and ACLs, and we'll deal with that as we're rebuilding the Proxmox lab. So with that said, I mentioned the other day we're going to be running a mixed bag of network hardware. Our network hardware, if we go back to Unifi and we look at our hardware and we look at our network, there we go. Must have just timed out on me. There we go, and we're in. So if we go back and we look at this, we'll do a quick rundown over what all this looks like. So my internet comes in to my USG Pro. That USG Pro then drops down to a US 8 switch, which is an 8-port with some PoE on it. And then from there, this switch, and you can't see them on here, but this US 8 then connects on one of the ports over to a Cisco 3560G. That 3560G then it sits in my garage with a cable coming out of my house into my garage, like I said earlier, and then the cable runs underground to the shed and plugs into another 3560. And you can see this very generally on the diagram, but I'm not going to jump back there right now. But then off of the 3560, we have this USW aggregation switch. And this USW aggregation switch is the 10 gig switch. This is the switch that all the server 10 gigs are plugging into. 2 per host with the exception of PVE1. And PVE1 is my worst server. For whatever reason, it just has some issues, and it's going to eventually be the cold standby. And it's also by far the most power hungry and noisiest. So that'll be good that we eventually can just shut it off. It can sit there as a node. And if the others die, I can bring it up, update it, make sure it's connected to the cluster, and then we're back and good. But all that said, this USW aggregation is going to have all these VLANs on it as well. So all of these data center VLANs. So let's go back to the diagram real quick. So if we go here and we look at this diagram, let's see if we can go to the 4-node. Yeah, the 4-node makes this a little bit clearer. So again, Internet, USG Pro, US8, 3560 garage, and then 3560 shed. And then that connects via 1 gig. It should be clear. It's 1 gig between the 3560 and the switch. The connections between both the USW core switch, the 3560G, the 3560G shed, and the aggregation switch are all 1 gig .1Q links. So .1Q is the trunking protocol, and that's what allows us to pass multiple VLANs over a single path. So right now, with those .1Qs, the default untagged VLAN on each of those is 1. So VLAN 1's natively going across. When we add these, we're going to have to add these at every single point. And I want to show just what that process is. That's the biggest thing that I want to show, what it looks like to set up a VLAN from the start of the Unifi network and where our core is, so where all of our gateways are landing for the VLANs, which right now is the USG Pro. That'll change later, but that's where it is now. And then it goes into the core switch, which is just the main switch where all of my other services aggregate out of for the whole house into other smaller or bigger switches, and then go from there. But we're going to start with the USG Pro through the interface configs and the VLAN and network configs. Then we're going to show what the US 8 core switch looks like. And I'm not going to do any testing there because all we want to do is we want to make sure the VLAN's there and it's tagging across. That is all kind of automagic in Unifi. We talked about this a little bit last time. It's kind of that controller-based networking that when you do something, there's some default things that just happen. I know they happen different on Meraki and other people's products, but in Unifi at least, when you make a VLAN natively, it kind of works its way out to all the devices. And by default, all of the ports on all USGs or all Unifi switches are natively allowing trunking. So it's pretty simple to set up from that perspective. On the two Cisco 3560s, if you don't know anything about Cisco, you actually have to go in and you have to put every VLAN on the switch that you want to transit. It doesn't have to have an interface in that VLAN, but the VLAN has to physically, or I should say configuration-wise, exist on the device. And I'm going to show that because both of these 3560s have now been moved back to VLAN 1. All of my network interfaces are on VLAN 1. So when we SSH into these, we'll be on VLAN 1. But when you come all the way over to the Shed 3560, I've got a laptop hooked up, a Windows laptop, and it's got the IP address of 10.1.10.5. That is going to live, as we know, in VLAN 10, our PVE cluster public interfaces that we were just talking about a minute ago. I'm not going to do all the config tonight. I'll probably do a couple of them. I might even, shut the mic off and just let the stream run while I do some work. Later, we'll see. But in general, we're going to do VLAN 10. Right now, behind me, back in the lab section without a camera on it, my laptop is just pinging away at its gateway. And its gateway will be 10.1.10.1. It's not getting an answer right now. The other thing we want to do is we want to start two shells here. And we are going to do ping -t, which tells us to just send continuous pings till we tell it to stop. And we're going to send it to 10.1.10.1.10.1. That's the gateway of the VLAN that we're going to create. And if you look, nothing's happening here. So I am on that default VLAN. I'm on a host. It's telling me that it either does not know how to get to that address on this network or that doesn't exist. We know it doesn't exist right now. The next thing we're going to do is we're going to go and we're going to ping -t, and we're going to do 10.1.10.5, which is that Windows host over there. Pretty sure this will work. I think I turned the firewall off. I might have to go screw with that. So if I do, my apologies. But there's no smoke and mirrors. I'm not unplugging cables. This is all just configuration at this point. The other thing I want to point out here is as we do this, you need to be careful moving VLANs around. Just like I found where I was putting myself into loops and stuff, there are unintended consequences. There's also unintended consequences if you try to change the default VLAN or the untagged VLAN on a trunk. You could lose access to a whole infrastructure. So if you're, say, on Cisco gear and you're 100 miles away from the site and you change the tagging and you don't go through the right order of operations and you don't go through the right steps, you could isolate one part of the network from the other. You can also do that with L3 just by I'm going to change the IP and not even think about it, and then not have a way to back out, not having had a bad network, not have a console server, not have a lot of things. But there's a lot of ways, ACLs, port changes, all sorts of things that you can actually isolate yourself. We're going to probably run into some of those, and if we do, we'll deal with them as we go. But this should be a pretty straightforward one tonight, which is add a VLAN, extend that VLAN across the entire .1Q trunking path from the core all the way to the aggregation switch, and along the way, enable access to that. So with that, just so we're clear, right now, the only things we're pinging is we're going to be pinging the gateway that lives here. We can go back and look at it here. It'll be this gateway right here as I move that around. One of the things I don't like about Miro. It'll be that VLAN right there, interface that we'll be pinging. And the actual laptop is sitting right off of here. So if we go and do a shape and do all shapes and do laptop, I'm sure there's a laptop one somewhere. Laptop. There we go. Good old Cisco. So there's a Cisco icon. Our laptop is sitting right there. So just for reference in this, we'll know what we're doing. All right, enough talking about it. Let's do it. So we are going to jump over to the Unifi controller again. We're going to get out of the maps and all that stuff. And we're just going to go straight to the networks. Once we're in the networks, we're going to say, create a new virtual network. The network name, we're going to go reference from our list here. And by the way, there's another dirty trick. I should probably show you this before I do it. I got Netbox up and going and using Netbox the way it should. If you don't know what Netbox is, I'm probably going to do whole videos on that later. But Netbox is a data center management IPAM organization tool for all of your kind of data center network needs. And if we go down into the IPAM portion, we created VLANs and all of that and all the components for all that here. And if we go look and we look at VLAN 10, it's called production server VLAN. So eventually, and I don't know how much I can do with Unifi. I know I can do quite a bit with Cisco through some of the tools that are out there. But eventually what we should be doing is using automation to pull things from here as our source of truth and then make them happen in the network. We're not going to do that today, but I wanted to use some consistency. So let's just copy production server VLAN. Let's go into the Unifi. Let's paste that. Going to have some extra spaces and stuff. We'll clean those up real quick. And then from there, it's going to be, it tells us where we can put it, which gateway. We're keeping it on the USG Pro. It's going to be IPv4. We want to shut off auto scale. Auto scale is something that Unifi does to scale your network dynamically. We're not doing that. We're treating this as a brand new subnet, VLAN, all that stuff. So we're going to do 10.1.10.1. That's the host address. We're going to give it a net mask of 24, which makes it a Class C network, and we see that there's 254 usables. That's all there is to this as far as just setting up the basics. And then you'll see the subnet mask and components down here. But then we wanted, in auto, it's just going to say it's VLAN 2, and it's going to give it some basic stuff. We don't want that. We want to go tell it more structured data of what we want. So we're going to choose manual. I'm going to change from VLAN 2 to VLAN 10. We are not going to isolate it or do anything yet, but this is cool because later we'll just be able to say, give us internet or cut internet access from this network. And on things like the network that we're going to use for the CoroSync per se, the CoroSync has no need to get to the internet. It has no need to talk to any other networks. There is zero reason that network should do anything. So when we build that WAN, and we'll do that one tonight and show it, and might have to pause and make a couple changes to validate it and show folks. But if we go back and we look for that network, what we'll do is we'll choose things like isolate the network, disallow that. And the next thing, it's just the network group. These are just the LAN interfaces off the USG. So there is the possibility to create very physically segmented local area networks on the USG, but we're not doing that. We're just using a single LAN port coming out, going to that US8 switch, and then going from there. Might use these later, but for now, single LAN port, everything aggregates to it. Think of it as your edge router / firewall in your enterprise. All right, so with that said, we're going to allow internet access. We're not going to isolate it, LAN group. I don't know what we're going to do on this, and because we're going to have a whole bunch of different types of servers living on this VLAN, I'm going to enable IGMP Snoopy and multicast DNS. These are things that allow us to do, so like multicast DNS is what allows you to do, I'm totally blanking, but like being able to see different devices in different, like two Samsung devices can talk via MDNS, multicast DNS, say, I'm here, hey, I'm here. Apple stuff does it and screams at each other. And it's how the stuff kind of magically populates without you doing any config. There's some interesting things here, IGMP, Snoopy, and multicast DNS. We'll leave those on for now. I should point out that the Unifi USG Pro is, I think, limited to 5 of each of these. So only 5 ports that can, or VLANs that can do IGMP snooping, 5 that can do multicast. There's some limitations, but we're not going to need them all anyways. And we could probably shut them off, but if we ever decide to turn up a media streaming server or something like that, the multicast DNS components will be helpful. All right, moving on from there. It also says, do we want a DHCP server? My answer is no. I don't want a DHCP server for this, so I'm going to say none. I'm also going to turn on DHCP guarding, or not turn it on, but leave it off for now because there's no DHCP. Or maybe we will. If we do one, it would be 10.1.10.1, which we're running all of our DNS out of here. Yeah, so what this does, this just protects us from another DHCP server coming up, whether it's in an application, in a real enterprise, if it would be something malicious, like somebody trying to put a device on to like do man in the middles, get the IP address, then forward it back to the network, that type of stuff. We're just going to say anything on this VLAN should only get their DHCP from 10.1.10.1. And we're not doing it right now. We're not having one because these are all going to be statically allocated servers as far as I'm concerned. We might change that at some point, but right now, my opinion is server networks stay static. I've been in networks before where they'll go into DHCP and they'll statically assign them there, and that's good enough. I've seen problems with that where the DHCP server goes nuts and then you've got a bunch of screwed up leases and the databases don't match and there's a bunch of stuff there. But I've also seen it where you'll actually statically assign it and you'll set DHCP static assignments. That way, if somehow the server ever gets a NIC update or anything and it goes back, it'll automatically assign the MAC for that NIC, the IP it's supposed to get, and that's one more thing. I've seen it done a bunch of different ways. I really don't have an opinion right now on it. I'm just statically assigning. I'm not adding DHCP. Like I said, I've got that box back there pinging. I've got the hosts here pinging. The box back there is just trying to ping its gateway. It's not going to get there yet because I'm just turning up the gateway. I still have an entire .1Q VLAN path to build out here in a minute. So if we click and add this, we're now going to see we have production server VLAN, VLAN 10, tells us our router. It tells us the subnet it's on. There it is. We're good to go. So if we then go down to our pings, you'll look and see that we don't have any of this stuff going yet, but suddenly it appears. This is that magic of Unifi. So that 10.1.10.1 is the gateway. What happened is all of that VLAN got propagated throughout my entire Unifi architecture. And if we go and look at, so let's go look at Unifi devices. Let's look at wired. And let's start with the US 8 switch. And then we go down to port manager. And at port manager, let's say you can see all the things is attached to. Like this one is the one that's attached to the garage one. If you look, what it says, it's port 8. It's active. It's default. It allows all VLANs. We're allowing every single VLAN. We could go in here, we could do custom things and select the tag VLANs we want, but we're not going to do that. And by natively, without doing any config changes, the untagged VLAN, the management default VLAN, is always one in Unifi. So we don't ever have to mess with the untagged one or the default VLAN for Unifi. It's just all part of the magic. But again, let's jump back here and we look. We're pinging it. We're not pinging the actual host yet. You're seeing the response from my gateway saying it doesn't know how to get there. And that's because we haven't gone the rest of the way down the route. So let's do that now. So we're going to jump over into a terminal. And I am going to go to 192.168.1.41, which I'm pretty sure, is the garage. And this might be a little hard to see. We'll see how this turns out and see. Well, let's just see if we can do it right now. Is there anything we can do quickly? I haven't messed around a whole lot with this. Yeah, I'm going to say there's probably not a whole lot I can do right now without totally wrecking this session. So let's not do that. I hope you guys can see it. We're going to enable, which is just how we get to the management mode on the Cisco devices. There was also SSH stuff that I've got cached inside of, what product is this? I just started using it. Help. MOBA Xterm. I was a big fan of Secure CRT, but I don't have a current copy. And these Cisco devices use old hashes that Windows no longer sees. So you need a product like, either need a Linux box or you need to do a bunch of hoops to jump through, or you can just get something like Secure CRT, PuTTY or MOBA Xterm. And MOBA Xterm so far has been a really clean kind of replacement for most of the things that I would have used in Secure CRT. And since I'm not doing a lot of network work right now, I don't need a copy of Secure CRT. I don't need to pay for it. MOBA Xterm's a really good product for that. A little bit more complex, but a lot more features. So, all right, so we're in, and then we're going to do show VLAN, because I want to show you guys from the jump, there's nothing here. So these 1,000, 2, 3, 4, 5, these are all predefined ones. These aren't anything you do. These are just on the switch. And there's a lot of other better descriptions that go into VLANs and stuff. But for a lack of a better term, it's exactly what it says, a virtual LAN, a VLAN. It allows you to use a single piece of hardware or many pieces of hardware and segment them into their own LANs. A lot of different reasons to do this. You can segment for security. You can segment for collision domains, so all like the broadcast domains. So I've been on networks that literally had thousands and thousands and thousands in the same L2 network in the same collision domain, and you were getting all sorts of retries and drops and everything else. Not as big of an issue in modern networks, but still just the proper experience to segment networks to the size they need. And you're going to see me, for now at least, on everything that we do in these VLANs use /24. 254 addresses, way more than I'm ever going to need for any single VLAN / single network in my network. So with that said, you can see all these ports, I move them back to the native VLAN. That's all they're on. So with that said, we're going to go into config mode, which is conf t. I'm probably going to do some things that are wrong in new versions of iOS, but generally iOS commands don't change, and a lot of iOS commands reported to NXOS, iOS XR, and XE. We're not dealing with that. These are just old plain Jane L2, L3 switches running iOS. I don't even know what version. Do show ver. I'm running software version 15.02. It's old. These things are dead. They're great for labs, but they're not good for anything prod anymore. All right. So from there, we're just going to do VLAN, and in this case 10, and I'm going to hit enter. And then I'm going to do no shut, which it shouldn't be shut. By default, they're not. And it tells me not shut down, but there's just a rhythm you get into when you've done this before. So then we're going to do exit. I'm going to do show VLAN. And if you look, now we have VLAN 10. It's active. It's not going anywhere. So then if we do show, in this case, CDP neighbors, because I know the other device I want to talk to is Cisco, I can see New Mexico Way, Shed 1, blah, blah, blah. And that is connected on port 24, actually on both sides. I like consistency when I can do it because it makes troubleshooting easier. And in this case, both of the kind of WAN uplinks or the campus, WAN uplinks or campus link is on 24 on this switch. So if we do a show int gigabit 0/24, it's going to show us everything. It's on here, all the different stuff. That port's up, it's passing, it's all that stuff. So I'm probably going to get some of these wrong. I'm rusty. We're doing this live. We're having fun together, right? So if I do show trunk, let's try that again. Show int gigabit 0/24 trunk. There we go. So by default, you're going to see now that I have added 10, it natively kind of does what Unifi does. It says that it's going to allow 1 and 10 across. Now, there's some interesting things about this now that we're traversing them across, and I don't think we have to really worry about them, but this is where we should define. So if we go back into the interface, and this is where I can screw things up. So as long as it works tonight, I'm not going to mess with this. We'll go back and figure it out later when I've tested a little bit more. But if we go back into config and we do config conf t int gigabit 0/24, and we do switch port trunk, and then we do native VLAN, here we should say 1. We should define the native VLAN as 1. And what this is this is the untagged VLAN. This is the VLAN that we saw that is just natively propagating around as the management one. I don't think it's going to cause any problems right now. And I don't want to lose access to these switches because then I'm going to have to pause the whole stream and record, run to the garage, run back, do a bunch of other stuff. I'm just not set up for cameras to do that. But maybe I should have a GoPro out here and then we can all experience the joys of breaking networks together. I've done this hundreds of miles away. Luckily, we've had people. I've done this on other sides of campus. I've done this in the middle of the night, middle of the day. Like, it's just things you do when you're coming up through the network field and you learn tricks and trades around it. But again, I'm a little rusty on this. I haven't been doing this stuff for a while. All right, so we're going to exit out of here. We see, again, that if we go back and we show interfaces trunk, we see that this is forwarding it. So then let's do this. Let's close that tab because it's an older tab. And we're going to go into this switch, which is the shed switch. And we're going to do the same thing here, but we're going to show a couple things first. So we're going to show CDP neighbors to just show who we're connected to. We're connected to the garage, which is another Cisco device. CDP is Cisco Discovery Protocol. Only works on Cisco devices. But it works on APs. It works with all their gear. Works with call managers, I think. So it's really good if you're a pure Cisco network to be like, oh, there's all my Cisco stuff. I don't know if it interacts with Meraki because I haven't done anything with Meraki in years since right after the acquisition. It may now. It'd be cool if it did. The other thing we can do here, just while we're talking about it, there is a link layer discovery protocol, or LLDP. So if we show LLDP, we have interfaces, traffic, blah, blah, blah. We're only interested in neighbors, just like CDP neighbors. It's very similar to the same thing. And if you look here, we have the USW aggregation switch, which is the 10 gig switch. We have the garage. We have a Mocha switch, which... Oh, that's the switch under my desk. It used to be connected via Mocha. I haven't renamed it yet. We'll talk about Mocha another time. And now it's connected via a straight gig copper Ethernet path in my shed. And then we have NMW AP shed 1. And that's right up over top of me. I have a Unifi AP mounted up there. So LLDP is something that's universally supported by almost all vendors. I'm sure there's some unmanaged vendors and some goofy vendors out there, but if you connect any device together and it's managed in any way, you should have some sort of LLDP communication between devices. And this is great if you're coming into a network for the first time and trying to troubleshoot, you're taking over a network, you just don't have your diagrams right and something's not working the way you think. You can go look at this and be like, oh, I have my notes with the port in the wrong place. It's super helpful. But anyways, so we've shown that. But to go back to this, we don't even have to, because Garage shows up in LLDP too. And we see that both of those are on port 24, just like we said. So then we're going to do show interface gigabit 0/24. We're going to get all the things that we did before, and then we're going to show trunk. And there you go. So if you look at this, you've got port 24, VLANs that are allowed, which is effectively VLAN all, because the VLANs go from 1 to 4094. But you're going to see that while they're allowed on the trunk, the only ones that are currently passing are 1, because it doesn't exist. So let's do this. I am going to screw with the screen a little bit here. I will apologize ahead of time if this doesn't go super well. But we are going to bring up these. And if you can see, my local host, the computer that I'm streaming to you guys on, is on the 192.168.1.1 network. It's on VLAN 1. It is routing via its WAN interface to the USG Pro firewall router across its backplane to its virtual interface to the 10.1.10.1 interface, and I'm able to ping it, and I'm able to get a response. This is a routing decision that's being made at the firewall to allow this to work. This will also be a routing decision, but right now the host doesn't have a path back to that route via L2. It doesn't have a way back to its own gateway. So if I look over my shoulder, I can see just on the other side of the room, it's not getting a ping response, just like this isn't. How do we fix that? We just extend the VLAN 10 across the trunk all the way. And in order to do that, the VLAN has to exist on every device in the trunk path. It has to exist on the USG Pro as the gateway, which then disseminates it to the US8 Unifi switch. Then manually, we had to instantiate it on the 3560G in the garage. And now we have to instantiate it on the 3560G in the shed. As soon as we do this, or after a little bit of spanning tree magic that make sure the ports are consistent, it'll come up and we should start pinging this. So hopefully it doesn't make me a liar. And we are going to go in here, we're going to do conf t, and we are going to do VLAN 10 and hit enter. And now we're going to wait. And like I told you, I get into a rhythm. We're going to do a no shut on it just to see. Oh, we're not done. I forgot something. I wanted to show you guys the entire thing. So the interesting thing here is the port that I'm plugged into, which I know for a fact, based on a post that I have right here, is in the shed on gig 09, gig 0/9. That is still in VLAN 1. It's still sitting as a native switch port, which defaults to VLAN 1. So if we exit this and I do a show VLAN now, we can see 10 there. If we go back to show int gigabit 0/24 and trunk, we can see that both 1 and 10 are now passing on the trunk. So we have extended the VLAN all the way from the USG, all the way over in the house, all the way underground, all the way to the switch here across the two Cisco devices. And strangely enough, we've also natively already extended it to the aggregation switch that hangs off the Cisco, because the config already got pushed out from the Unifi controller to it. And while it didn't have a path back to VLAN 10, VLAN 10 has already been set up and allowed on the aggregation switch just by the nature of the kind of the software-defined networking, controller-based networking functions of the Unifi controller. It's cool stuff. Eventually, maybe the whole network will be unified, but I like having Cisco in here too for lots of reasons. All right, so here we go. So then if we do show VLAN 10, show VLAN brief maybe. There we go. So yep, if you look, you'll be able to see all the ports that this is on. And if we stretch this out a little bit, you guys might be able to see it better. Let's do that again. Yeah, it shows it a little bit better. But what you see here is all these ports are still on 1. None of these ports have been turned into a host port for anything to talk to. So right here, again, we've got that laptop sitting there pinging to its gateway, which is 10.1.10.1 behind me. And here on the computer you guys are seeing, I'm pinging 10.1.10.5, which is the host address. I manually assigned that earlier before we started all this. So now we're going to go into conf and we're going to do interface gigabit 0/9. And then we are going to do switch port mode access. By default, it's in access, but again, these are just kind of rhythms you get into over time. Later, we will probably show how to build out and dump all the VLANs at once. And it's not automation, but it feels like it, or at least it used to feel like it back in the day, because if you configure your config file to deploy correctly, you can copy and paste in a huge amount of data and go from having a dead switch or a very lightweight switch to an entire enterprise config on a switch in just a matter of seconds. And if you screw it up, you can wait a long time for it to time out and do everything, but that's another time, another place. So we're switch port mode access. I like doing this. Giving a description is one of those things on a port that if you do it and you keep it up to date and you're really diligent about it, it will help you troubleshoot, help you find problems, just one more step beyond LLDP. So in this case, I'm going to say laptop test VLAN 10. That's all we're going to say. This just gives us a description. And let me show that. So if I do a do, and I didn't know this for the longest time, for a big chunk of my career, I would always exit all the way out of config. iOS has this really cool config after, I think, 12.4 or something. I'd have to go back and look, where you can just type do, and then you can do commands that aren't necessarily config commands. You have to be careful because you're still in the config. So if you mistype do or accidentally type the wrong thing, you can still screw up the config. But for quick and dirty stuff, you can do show interface gigabit show interface gig 0/9. Now here's another thing about this. If you notice, I was trying to tab complete. At least in my version of iOS, do commands don't tab complete like they do when you're just in enable mode, which is a little annoying, but it is right, whatever. So this shows the state of the interface, and you'll now see the descriptions up there. But we can also do show run, which will show us the config of interface gig 0/9. And if you look now, you'll see the description is laptop test VLAN 10 switch port mode access. We're not done though, because we've told it we want it to be in an access mode, which is a mode for a single host to attach to it. And then what we're going to do is we're going to do switch port access VLAN and 10. Now hopefully, if I remember all this is where the magic happens. And that's the other thing, if you're not used to Cisco IS, you can question mark at the end of everything and it'll tell you what other options are there, which is what I did just there to make sure I wasn't forgetting anything. So I'm going to hit enter, and if this works right, and Spanning Tree does its thing and everything's good, and everything else is configured through the rest of this, then we should start getting a return from the laptop, which is 10.1.10.5. And then I'll look over my shoulder, and it'll also now be able to ping 10.1.10.1, which is its gateway, which means it is now part of the routed network routing between 192, or VLAN 1 and VLAN 10 now. So the 192 network and the 10 networks. All right, here we go. We're going to try it. Waiting on Spanning Tree. I think we're waiting on Spanning Tree. Or I messed something else up. So we're going to do show VLAN 10, show VLAN. Oh, we got to change. This should be good. This should be the first sections of Spanning Tree coming back. And then we're going to do show VLAN and then summary. Shows our VLANs. And then if I show VLAN brief, it now says that port gig 09 is in VLAN 10, so we know that's there. We also know that it's trunked all the way back. We have a clean trunk path based on what we did earlier. So if I do show Spanning Tree VLAN 10, so if we look at it, it shows that it is forwarding on all the ports we'd expect it to. So 9, 23, and 24. Okay. 23 is the uplink to the Unifi aggregation switch. The trick here is I think we have a problem. So let me check something just real quick. I'm going to be right back. So the good news first, and you can't see it, is that the laptop is pinging its gateway. So the port configs are right, all that stuff's right. We're going to go in here and see if I screwed up my ping. So if I do that, yeah, and it doesn't look like I screwed up my ping. We should be doing ping 10.1.10.5-T. So the good news is that the laptop can talk to the gateway. I haven't tested it beyond there, but we have some sort of config issue. And that's the interesting thing about this. So I'm going to jump off headset real quick. I'm going to try to ping from that host into another network. It shouldn't work. If it does, then there's something goofy on my laptop or a firewall or something. But give me 2 seconds. All right. And my guess is I just solved it. I'm pretty sure it's a firewall issue on the host. And there we go. Yep. So just so you all know, all I just went and did is, because that's totally on a private network right now, I just went and disabled Microsoft Defender Firewall from the domain and from the private network. And it immediately allows us on. So I think I mentioned at the beginning, I might not check the firewall, and that's my bad. One more thing for me to kind of figure out in the future, do a little bit more prep work for you guys so it's a little bit cleaner. But this is how it works. This is how networking works. And what's interesting is when I started, firewalls were all at the edge. And then there were some between different zones. We had firewalls at the internet edge. We had firewalls that sat in front of our WAN routers when I was in the government. Every single edge site, so we had 200 and some edge sites in the government network I worked in. Each one of those had its own dedicated firewall to manage connections, because that network actually allowed routing to happen between the individual sites. They didn't all have to always come up and through our network, but some did. So firewalls back then were, for the most part, hardware devices. You knew where they were, especially if you were on your network. I think it was around that same time that things like Black Ice Defender was coming out. And Black Ice is a firewall to put on Windows boxes. I don't even know if Black Ice is still out anymore. But you didn't have a lot of edge firewalling, at least in Windows environments, which is mostly what I grew up on. A little bit of Unix, but mostly this. Now firewalls are everywhere. And the general concept is firewall as close to the host as possible. There's other aspects like do NAT translation as far out on the network as possible. You want to push a lot of services out to the edge. It used to be that when we were building networks that developers or sysadmins would come to network people and go, make this work. And that meant that we had to like buy proxies, or we had to like do policy-based routing, or we had to do weird things to make stuff work. The world's changed radically. And this is just one of those cases that everything has a firewall now. Your phone has firewall components. Your laptops have, like every OS has a laptop or a firewall component. All of our cloud services natively have firewall components. If we go look at Proxmox, and we're going to mess with this, we haven't yet, but if we go look at Proxmox at the host level has a firewall component that allows you to add firewall rules against different hosts and things. We'll play with that later. I'm super interested in this because, again, it's put the firewall close and put the firewall in a place that it can be managed. And there are definitely ways to manage firewalls at scale on Windows and Linux and stuff like that. But also, if you can use platforms and SDN and stuff like that to do it, then aggregate it where it makes sense. And it'll make sense for different people at different places. This is a good time to point out that not every network is going to be the same. Not only just for IP addresses and needs, but scale. None of us are the same. We're going to have to do things in best practice ways and in secure and stable ways that work for our businesses. So often you'll hear people go, oh, I want to be like Google. I'm guilty of this. When I went to Sauce Labs almost a little over 8 years ago now, I told my team, like, we are going to be running millions of VMs. That's the company's goal. Literally spinning up and spinning down millions of VMs and test instances daily. We need to be able to be Google. And Tyler Christensen, who may or may not watch this and who many of you may know, was like, you're an idiot. I think that was pretty much his exact words to me as his boss. But he was right. You can do things that are similar, but a 3-site mid-market company can't do things the way Google does. There's not that there's not lessons to be taken away from what they do, but then a web scale company like Sauce Labs was becoming isn't going to do things like Google. Sure, we can do things like Spine and Leaf and Clo networks and all sorts of cool, crazy things, which we did that allowed us to scale to millions and millions of VMs, but it's still not Google. It's still not availability zones everywhere and private fiber paths. There's their own hardware. Like, So just don't get wrapped up in that. Figure out the best way to securely and stably build what you need for your environment. And there are a lot of kind of blueprints out there by Cisco and Juniper and vendors in general. All that said, here we go. This is up and running and done and all that good stuff. Let's show making VLAN 11 just real quick and dirty. Let's go back through all this stuff real quick. So I'm going to minimize that. I'm going to bring this back to full. I am going to go back into my network management, and I'm going to go to Netbox because we're going to build that CoreOSync VLAN. And I'm just going to show you the quick differences, and then without all the hoopla over it, run through and just do all the checks again. We don't have a host on this network. I'm not going to go reconfigure the laptop or anything. I'm just going to burn you through it. You've seen it work. If you don't believe me, well, then networking's magic. So we're going to start at Netbox because Netbox is our source of truth. We're going to build out VLAN 11, which is CoreOSync VLAN. If you watch the others, you'll remember that CoreOSync is the cluster communication network between all of the servers in Proxmox. It's also used to build other clustering technologies. You can build quite a few clustering services out of it, but it's also touchy. It likes to have its own dedicated network. You can't constrain it for bandwidth. You can't put a bunch of other traffic on it. You can't have things dying on it. If you do, then CoreOSync gets really pissed off and things don't work right. It's better from what I've seen from what I messed with 8 years ago when we started at Sauce, but it's still a little touchy. So we want to create a dedicated VLAN for it. We want to put a dedicated interface, not a shared interface, not a .1Q with a VLAN. We want a dedicated interface for CoreOSync. In our case, it's only a gig. CoreOSync doesn't use a lot of traffic. We'll look at traffic metrics on it later because we'll do SNMP graphing for all of our switches at some point and show what different things do. But you're going to see, once CoreOSync's up and doing its job, it's a small requirement, but it's got to be stable. So we're building that now. So we start with source of truth, VLAN 11, copy the name, go to Unifi. We're going to go into Unifi config. I'm going to tell it to leave with unsaved changes because that was just me showing things. I don't want to actually make changes there. The other thing some of you might notice real quick, and I jump all over, I'm sorry. My Unifi config might look different than other people's. I had the old Cloud Key 1, and it just wasn't supporting the things I needed anymore. So I went to self-hosted Cloud Key. This is the self-hosted instance, and it's kept pretty up to date. But there's features that it either doesn't have or that my hardware doesn't have. Like I can't do certain types of VPNs on it, and I don't know if that's a component of that. My gateway doesn't support that, or if the cloud, or if my Unifi controller doesn't. But either way, it's an up-to-date version of the Unifi Cloud controller, but it's just self-hosted in my lab. And I think we talked about some of the challenges that come up out of that last time too, where you can isolate your controller and then things don't work right. But for now, we're back to building networks. VLAN 11. So we're going to go to new virtual network. We're going to dump the name. Again, it picks up some other content with it. We're going to clean that up. CoreOSync VLAN. We're going to go to that. We're going to undo autoscale network. I kept the networks easy. They're all 10.1 with the third octet being the VLAN number. It's just easier that way in a small environment. Big environments, that doesn't hold true. Carriers, that doesn't hold true at all. Service providers and those folks doing a bunch of NAT, that all goes out the window. But for us, our networks are nice and clean so we can keep track of them. Again, gateway address is 1, shows broadcast, shows us 249 usable IPs, 254 usable hosts, shows the range, shows the subnet mask. We're going to go to manual. We're going to change VLAN 2 to VLAN 11. Also, you guys can see this, but, you know, we don't need to click through 10 million things, so we can type 11. In this case, we're going to tell it isolate network, and we're going to unallow internet access. I don't want any other network to be able to ping that network. I don't want anything on that network that gets loose in there to suddenly be talking to the internet. It is CoreOSync. There are... I've been talking for too long. Excuse me. You're probably going to find people who counteract me. That happens in tech all the time. We all disagree on things. Maybe I'm just being too paranoid about CoreOSync, but I can tell you just from running my own home lab, I flooded out the interface. I broke a bunch of stuff, blah, blah, blah. So we're just going to defend it. So it's its own isolated VLAN. We're not going to do multicast in there. It doesn't need it. It's not going to get a DHCP server. However, we will enable DHCP guarding just like we did before. And we will just tell it that the only person who can ever give DHCP to that is this gateway. And that's only going to happen if this turns on. Then we're going to click add. Once we click add, if we hurry up and jump back over to here, you're going to see that these are showing getting ready and up to date. And the USG Pro is still getting ready. He'll click over to up to date here in a minute, hopefully. But what this is, and you only caught a real quick glimpse of it. And there it is, up to date. Orange is it's sending out configs, and you'll see the status, getting updated, whatever. And then up to date. And this just shows that everything's in sync. This is my APs, my switches, everything. This just shows that everything's on the same page. And as of right now, that VLAN, so VLAN 11, exists on every single piece of Unifi gear in my network. Sorry, somebody's on here. Somebody's actually watching. Hello, sorry for bothering you. I want to offer a promotion on your channel. No, thanks. I think that's a bot. We'll ignore the bot. I was hoping it was actually one of you. So moving on from there, we're going to go back into our SSH sessions. We are confused by how Mobiterm works. All right, we're in the shed. So all we're going to do here is we are going to do show VLAN brief. VLAN doesn't exist. We're going to do conf t. We're going to do VLAN 11. We're going to do no shut. We're going to do exit. We're going to do show VLAN brief. And now we're going to show that VLAN 11 is active here. We're all going to do show interface gig 0/24 trunk. And we're going to see that across 24, 1, 10, and 11 are allowed, as you can see. And VLAN, all these are in forwarding state. VLANs and spanning tree for forwarding state. Okay, and those are in forwarding state because there's actually traffic crossing them. We would get forwarding state, I think, if, and I might be wrong on this, but if somebody was actually communicating across that, we'd get it in a forwarding state as well. It just doesn't need to forward. It just needs to be there. And we could check that again on the next one. So then we're going to do a write mem. That just says write what we did back to the config. That way if the switch reboots, it all comes up normal. Cool. So then we're going to jump to, and I did this backwards. I did the shed first. I should have done the garage. You should always work from the center out. And I mistook that in my mind, mainly because when I redid the numbering on these switches, I didn't do them from the center out. I went the core, then I said my shed switch is 40, and I said my garage switch is 41. I should have flipped them just for logical process. Again, you don't always get that, but the way I was taught is you work from the center out, not from the edge back in, because that's how you get into problems. In a case, there's always exceptions to the rule, but as general. So then we're going to go from shed. We're going to go to garage. Get logged back into the garage. And we're going to do show VLAN brief. We're going to see no VLAN. We're going to do conf t. We're going to do VLAN 11. We're going to do no shut. We're going to do exit. We're going to do show VLAN brief. We now see VLAN is active. We're going to do show interface gigabit 0/24 trunk. And there you go. And actually, if you look, now that it exists in the whole path, you see it come up between the two devices that spanning tree is forwarding all of those VLANs. So it's not about having a host port active. It's about having the VLAN actually extended across the entire switching architecture. So there you go. And if we jumped into this right now, what I would be able to do, I would be able to ping its interface from here. I'd be able to ping 10.1.11.1. I wouldn't be able to pass that. Past that, it would apply the ACL that it said by isolate this network that says, sorry, nobody else can talk to this network. Only this network can talk to itself, unless it goes to the internet. And at that point, it would also allow it to talk out the interface, but I don't think it would allow it to talk to the local DNS. We'd have to play with that, but neither here nor there. The other thing is, because of that isolation, if I had a host on this right now, it could ping its gateway. It couldn't ping into this host or into any of the other servers or devices, say on 192.168.1 network. It couldn't, because there's an ACL in place saying stop. And that's exactly what we want. We want that core sync network, for all the reasons I've already defined, to just sit there and do its thing and not be bothered by anybody else. So beyond that point, you've seen how we set up a network starting at the core. It's a little bit different in this case because we're dealing with Unifi, and Unifi has its own magic on how it distributes all the configs and does all that stuff. But this would be very, very similar on another device. And I could even show you on the 3560s, and we probably will way down the road, because my guess is what we're going to eventually do is I'm going to segment the house and the shed via L3. So what we'll do is we'll create an L3 path, or a layer 3 path, an IP path, not an L2 or an Ethernet path between the house and the shed. And then what that'll do is that will give us the ability to do more IP ACLs. It'll allow us to do more routing. And then what I can do is, let's say, for example, I do all Unifi at the house, and then I decide to do all Cisco here. I get an Nexus 10 gig switch. I get a Cisco AP, which I actually have some old ones that we hook up. I just decide to do Cisco all in the shed. And I treat it as a Cisco site and a Unifi site so we can test interop between them. Well, then I could bring the two 3560s here, create a collapsed core, do the VLAN gateways for the data center, or the shed in my case, on those devices, do HSRP between them, or hot standby routing protocol, which actually keeps VLANs routing going between the devices. So if you pull one switch, the VLAN still routes to anything that's connected to it. There's lots of cool things we could do, but those 3560 switches can act as full L3 routers as well. And dirty little secret, and I don't know who else does this, but back in the day, the 3550 was kind of on the downcline when I started my career as far as L3 switches go. And the 3550 could do L2 and L3 just like the 3560 did, with the right OS image on it. And it was only 100 meg switch, and it had 2 gig GBIC ports on it, maybe 4 depending on what the switch is, but not many. But GBICs, which are precursors to SFPs. Now I'm getting really geeky and into the weeds. But as people threw those out, or as I was given them for labs, I kept 2 in my trunk at all time. And I'll tell you why in a minute. But I then eventually did the same thing as 3560s. 3560Gs started kind of going down. I was lucky enough that I had a couple clients who expanded quickly, and they went to like Catalyst 4500s and Catalyst 6500s at the head end. And they're just like, we don't want all these stacks of individual switches where we can manage it in a big chassis. So I got a couple 3560s. And what I would do is I keep 3550s or 3560s in my trunk when I was a young network engineer. And many, many times I would go to a cutover for a university or a small business out in the middle of nowhere. Cutover was going to happen. I was just asked there to support from the VAR, to make sure there weren't any problems, to interface with Cisco, and to bring expertise. But the network team generally usually thought they had things handled. On multiple occasions, what we found is things like they were doing a full L3 cutover. One mid-sized university in Ohio thought that their top switch, which was an HP switch, was an L3 switch. And they brought in this big new, I think it was a gig connection at the time, which was a big deal back then. It's not a big deal now. I have a gig coming to my house now. But that connection came into their new router. The router was hosted by the ISP. They chunked their old router. It was still there, and we could have used it, but it was like an old serial router for T1s and DS3s, and its throughput was very limited. Like it could only do like 45 megabits through the entire chassis, and now we're bringing a gig into it, and like the interfaces on it that were Ethernet, it was like serial and then two 1 gig interfaces that it just wasn't going to cut it. So even if we did jump through it, they were going to go from probably like 45 meg max to like 100, and they just bought this gig circuit. So what I did is I went out to the car. I went, hold on. I went out and got my 3560s. I went, this is a Band-Aid. We are going to have to buy real gear. We are going to have to get it in, config it, and do another cutover. But we're going to take these two 3560s or 3550s. We're going to set up all of your routing on them because the routing had been on the router before. They had done sub interfaces and VLANs off the router before. We're going to move all that config into true VLANs. We're going to do HSRP so we have some redundancy because these are used switches. And then we're going to plug in your core switch, which is just a big layer 2 switch for them. And then we're going to bring you up. So what was we're not going to get this gig link up tonight, and how do we talk to management tomorrow about our mistake, turned into, oh, it's up, it's fine, but we found some things, and now we're going to have to give our Cisco vendor some business. And usually what it meant is they went and they bought whatever the new version of 3560s was. Or I think there was a 4080 or 4050 that was a data center switch. It was effectively a little Cat 4500 or a Cat 6500 in a 4U box. They were great. I used them all over the place. And they were way cheaper than full things. My whole point to this is old gear, especially L3 switches that had like 36 gigs of backplane capacity and full routing capabilities, at least static routing capabilities or EGRP or basic routing capabilities, can be incredibly powerful. And if I ever get back into going into the field and doing it, I'm going to find my new version of the 3560 because I will run into this again, especially with more and more connections from carriers being Ethernet handoff or fiber handoff. Oh, well, we've gone for an hour and 17, and I don't see that any of you popped in. But again, a bunch of you are going to watch this after the fact, I think, based on what I've seen. Thank you so much. This is awesome. It kind of runs away with me, as you've seen. I love talking to you. I love doing this stuff. I love to be sharing what I've done over my career and what I'm doing again. So with that, have a great evening. Thanks for your time, and I look forward to seeing you all again.